You little monkeys. I had no idea. Why didn't you tell me? I'm sitting here writing like a nincompoop. When do I ever talk without writing? I didn't know. I didn't know. But there's your the help. Sorry, Sia, it was just me. I was being a nincompoop. We can all thank Yvonne. Okay, then for the other question that came in here. Explain why negative 2n squared plus 9n minus 11 will never have a positive term. I'm going to give you guys 2 minutes to give that one a try as well, and then I'll go through it with you. But you don't need to do completing the square. My hint here is think about a parabola and its turning point. Yeah, there you go. Yeah, but if it still works, you'll still get the marks. But I'm curious as to why it did work. So if we care about the turning point of the parabola, we care about minus b over 2a. That's what we care about. So we care about minus 9 over 2 times negative 2, which is negative 9 over negative 4, which is going to give us positive 3 over 2. That is our x value. Then we sub it in to get our y value. So therefore our y value is going to be negative 2 times 3 over 2 squared plus 9 times 3 over 2 minus 11. You should get, hold on, wait, I don't know how I've simplified this. Like, I'm just being a full-on nincompoop today, guys. There's no reasoning behind my nincompoopness. You pop that into your calculator, you should get a negative number. And because y is negative, it means that if we had a graph, our parabola is going to be chilling down here, which means there are going to be no positive values. Exactly, it has a negative maximum point. Nope. Okay. Take a screenshot if you'd like, and then let's get into measurements. An emotionally charged essay. Okay, let us begin measurements. We're going to start with something nice and simple. We're going to start with a little box over here, your rectangular prism. Now, a rectangular prism is what we have been calling assumed knowledge. So that means they won't have to give you the formula for this. It's assumed that you know it from grade 9 and grade 10. Do you remember your surface area and volume, what the difference is between them? I know it's been a long time since we've talked about this. What's the difference between the two? Yeah, good. Surface area is your outside. So it's basically like if you had to think about wrapping it like a present, it's the outside of the shape. And then the volume is your inside. So it's the capacity. When we were talking about surface area, since we're dealing with centimeters, it'll be centimeters squared. And when we're dealing with volume, it will be centimeters cubed. Do you want to give this one a try? Grade 11 syllabus is mean. I mean, yes and no. There are parts of the trick which may seem harder, but for the most part, no. It's just a continuation of your grade 11 work. Two more minutes. No, don't be stressed for next year. You'll be fine. Plus, now you're the smartest in the grade. Okay, let's break this down. When we're talking about volume and we're talking about a prism, the general idea, so wherever you can, is you want to take the area of the base and then you want to multiply it by the height. So in this case, this down here is the base of my rectangular prism. So I want the area of that, and then I want to multiply it by this height. The area of the base in this case is just a rectangle, so it's just going to be 30 times 12. And then we're going to times it by our height, which is 5. And that should give us 1800 centimeters cubed. And it's centimeters cubed because we're multiplying 3 centimeters. That's why we're cubing it. Okay. And then for our surface area is, we've got a whole bunch of different sides. We've got this side over here, and it's identical to this side over here. Then we have our bottom base, which is identical to our top. And then we have the front, so this one over here, which is identical to the back. So all we have to do is we have to work out those areas and multiply it by 2. So for our surface area, I have 2 30 times 12s, so that's my bottom, plus 2 12 times 5s, plus 2 30, what am I missing? 12 times 5, 30 times 12, 30 times 12, 30 times 5, that's what I'm missing. And if you chuck that into your calculator, you should get 1140 centimeters squared. So this is something that you would have to know. They're not going to give you the formulas for these ones. How did that go? Did you remember things? Did it come back? Or was this like completely gone knowledge? It came back. Okay. I'll take that. Okay. Take a screenshot if you would like, and then we can move on to our next question. Okay. All right, next one. We have a cylinder. Again, a cylinder is considered assumed knowledge, which means they don't have to give you the formula. But remember, The same idea goes for volume. It's always going to be area of base times the height, if it's a shape where the base is consistent all the way up. And what is the area of a circle? How do we work out the area of a circle? Now we're really pulling on your grade 9 knowledge. Pi r squared. Good. Okay, I've put some things on the board to try and help a little bit. Your surface area should be less than your volume in this one. Let's see. Okay. All right, last 2 minutes. Okay. So for this one, let's do volume first. So our volume is our area of our base times our height. So the area of our base is going to be pi. Now our diameter is 6, which means our radius is going to be 3. So pi times 3 squared, that's the area of our base. And then we're going to times that by our height of our shape, which in this case is 10. And so for our volume, we are 282,74 centimeters cubed. For our surface area, if we had to break this shape up, what we land up with is 2 circles and a rectangle. So for our circles, they have a radius of 3. And for our rectangle, this is the outside. So it's the circumference of the circle is this length. And to get the circumference of a circle, we do, does anyone remember how to get the circumference of a circle? You can either think of it as 2 pi r or pi d. And this is the 10 centimeters. So you need to work out the area of these 2 circles. And then you need to work out the area of this rectangle. And you're going to add those all together. So the areas of my circle, these 2 over here, I have 2 of them. So I've got 2 times pi times 3 squared plus 2 pi r, because that's my length. So 2 pi times r times 10. And this is our rectangle. So that's our length, and that's our breadth. And you can pop that straight into your calculator like that, and you should get 245,04 centimeters squared. Do you see now why we have to go through measurements? Because otherwise you're not going to remember these if they come up in your exam. Yes. Because it's not hard. It's just that we haven't done it in so long, so your brains forget about it. And then it becomes like a silly place to lose marks, because it's not like it's hard. Because, for example, they could even use like a measurement question in a patterns question. Like you could have to work out the volume of different shapes as like in the pattern. It's because it's that assumed knowledge. It is disturbing, yes. Okay. Let's see. Oh, one of my lines has gone awry. Let's fix it up quickly. So what we have over here is an equilateral triangle. You can think of this as a triangular prism, not isosceles, equilateral. So all of them are equal to each other. No problem. So for this, you're going to need a couple of things. So this is a triangular prism. Remember, when we talk about the base times the height, it means the base has to be the same all the way up. So in this case, our base is actually this triangle, and this would be our height. Because basically when we do it, it means I need to be able to cut anywhere in that prism and I would get exactly the same shape. So like if I cut here or if I cut here, I'd get the same shape. So now we need to figure out the area of that base over there. And in a triangle is half base times height. This is a special triangle because it's an equilateral triangle. Which means that all of those sides are 12. Which means that if I cut this down to have my perpendicular height, this will be 6 and this will be 6. So those are special rules of an equilateral triangle. And if I have that, then I can figure out my height. And if I can figure out my height, I can figure out the area of my triangle. And your friend here is going to be Mr. Pythagoras. Let's see if people agree with you, Abu. I'm going to draw my triangle a little bit bigger. We're getting some different answers. Let's see. Carry on trying. Let's see if you're going to be on Team Tebogo or Team Abu. I had to. Yeah. Couple more minutes. This is a lot you have to do for this one. Okay. Let's break this down step by step. The first thing that we have to figure out is we have to get this height because we need it for everything, basically. So let's think about our Pythagoras. If we broke this triangle up like this, we've got a height, which we don't know, 12 over there and 6 over here. And remember, Pythagoras is that c squared is equal to a squared plus b squared. And c squared is your height. Oh, what am I writing there? Hypotenuse. No. Hypotenuse. There we go. So for us, we're going to say 12 squared is equal to 6 squared plus h squared. And then we have to give a reason because it's maths, Pythagoras. So h squared is going to be equal to 12 squared minus 6 squared, which means h is going to be the square root of 12 squared minus 6 squared. So that means that h is the square root of 12 squared minus 6 squared, which gives us 6 root 3. Okay, so now we have our height, 6 root 3. Beautiful. Then we can start doing our next mission. So mission over here is to find the area of our base and then times it by the height of our shape. So the area of our base is this green triangle. And the area of a base is half base times height. My base is 12. My height is 6 root 3. So my volume is going to be half base times height times the height of the shape. Which is going to give us, let's see, half times 12 times 6 root 3 times 20, which gives us the beautiful answer of 1247,08 centimeters cubed. That's step 1. Now we have our volume. I would have given it to you. And now we need to work out our surface area. So for surface area, we've got these 2 triangles. So we've got the front triangle and the back triangle. So let's start with that. I'm actually going to move down so we have a little bit more space. I don't have a lot of space. Okay. So my surface area here, I've got those 2 triangles. So that's going to be 2 times half 12 times 6 root 3. Those are my 2 triangles. Then I have 1, 2, 3 rectangles that are all the same. So I'm going to add 3 rectangles, which are 20 times 12. So that's going to give us 3 plus 3 times 20 times 12, which is going to give us 844,71 centimeters squared. Take a screenshot if you would like. All right, this monster we're going to do on Thursday because I feel like it might break your brains tonight. And I don't want to break your brains just yet. So we're going to do this dude on Thursday. But don't panic. You would be given a formula for a question like that. Okay. Which one do we want to do? Oh, spheres. How are we feeling with spheres and hemispheres? Let's try this one. I will go back to the cone. First, we're going to do this one, and then we'll go to the cone. I didn't want to scare you with scary shapes this evening. All right, in this question, if the surface area of a rectangular prism is 36 centimeters squared, what would the surface area of a rectangular prism be if all of its sides were 3 times larger? It's a good start, Abu. It's a good start. Why don't you give them values to try? Like, think of it as a hypothetical. So hypothetically, if this was 1 and that was 2, just thinking, just giving you hypothetical possibilities here. We'll make this like 3, 2. Two more minutes. And then we can talk through this one. So is no one impressed by my beautiful rectangular prism? It's majestic. The question is saying, what would the surface area of the rectangular prism be, the one that is 36 centimeters squared, if all of its sides were 3 times larger? So when we have a question like this and we're not entirely sure what to do, the best way to go about it is to think hypothetically. We'll give it values and then we can kind of work out from there. So if we think about these values, right, my surface area would be 2 times 1 times 3 plus 2 times 3 times 2 plus 2 times 1 times 2. Or we could just write it as 2 times 1 times 3 plus 3 times 2 plus 1 times 2. Those mean the same thing. So let's figure out what that's going to give us. So we've got 6 plus 12 plus 4. So that is going to give us 22. So now let's think, cool, if that's what that was, now let's imagine everything was 3 times bigger. So now instead of a 1, that's a 3. And instead of a 3, that's a 9. And instead of a 2, that is a 6. So now my surface area is going to look a little bit different. So now it's going to be 2 times 3 times 9 plus 2 times 9 times 6 plus 2 times 3 times 6. We making progress? So we've got 2 shapes here. We've got the 198 and then we've got the 22. If we're trying to figure out what the difference is between them, take the 198, divide it by the 22, and we see what we get. And we get the beautiful answer of 9. That means that it is going to be 9 times bigger. So what we can do is we take our 36 centimeters squared times 9, which means that our new surface area is going to be 324 centimeters squared. Well done for figuring it out, Abu. Take a screenshot if you would like, and then we can move on to our next question. Okay. Which one do I want to give you? Let's do this one because it's quite similar to what we've just done. So I think it'll be a good way of thinking. So if the volume of a rectangular prism was 40 centimeters cubed, what would the volume be of a rectangular prism in which the scale factor was 4? So it's asking if it was, each side was then 4 times. The previous one was 3 times, this one would be 4 times. And this is talking about volume and not surface area. So again, think of it as a hypothetical. There's some help on the board. So Abu, do you see the trick? If you were given this question in an exam? Good. Exactly. Once you've got the pattern, you don't need to. Exactly. So let's have a look. Our volume for this one. So the area of our base times our height, right? So 1 times 3, the area of our base, times our height, which is 2. So 1 times 3 is 3, times 2 is 6. Okay. If we multiplied those all by 4, now the area of our base is going to be 4 times 12 times 8. So we're going to have 48 times 8, which is going to give us 384. So now let's have a look and see how these relate to each other. So 384 divided by 6 gives us 64. Now that's quite interesting because if you think about it, they told us it was a factor of 4, and they've told us it's volume. So volume is when I multiply things 3 times. If I write 64 with a base of 4, it's 4 times 4 times 4. So all I'm doing is I'm taking that 40 centimeters and timesing it by 4 times 4 times 4. And there's 3 of them because it's volume. So my new amount is going to be 2,560 centimeters cubed. I will come back to this, so don't panic. If we have a look at this one, the reason I said it was interesting is because this is 9, and this was talking about 3 times larger, and it's surface area. So it's the same as saying 3 times 3, and there's 2 of them because it's surface area. So if it's volume, it's going to be 3 of them, and if it's surface area, it's going to be 2. But again, you don't have to memorize that. You can always work it out with hypothetical numbers. If you would like a screenshot, please feel free. And then let's try sneak in one more question. Okay. Oh, what about this one? Oh, wait, hold on. No. Okay. Very similar idea. Now you can kind of take into account what we just spoke about. So this one should be quick sticks. So we can do this question and the next one because we'll be able to do them quickly. Think about what we just spoke about. So if the volume of a rectangular prism was 32 centimeters cubed and the scale factor of a new rectangular prism was half, i.e. each side divided by 2, what is the volume of the new prism? So we're going to do exactly what we just thought about now. We're going to take that volume. And previously, where we would have times it by 4 times 4 times 4, we would do that same idea. So our new volume is going to be 32 times a half times a half times a half. You're only now starting to like maths. Lies, you love maths. And that is going to give us 4 centimeters cubed. So this is the pattern that we've already figured out. No, you liked patterns by the end of patterns. And you liked Euclidean geometry. No, lies. All right, last question of the night. Same thought pattern. If the surface area of a rectangular prism is 32 centimeters squared, and the scale factor of a new rectangular prism was half, what is the surface area of the new prism? So same thought pattern here. You're working with this dude now. I definitely don't hate your answer, Abu. So surface area, we now only do it 2 times. So our new surface area is going to be 32 times a half times a half. And there's going to be 2 of them because it's surface area, which means it's going to be 8 centimeters squared.